Hi, my name is Daniil, and I'm glad to introduce here my talk on how to migrate from Monolith to Microservices, a guide to seamless transitions. Today, we're going to talk through 5 parts. The first one is the architecture overview. We're going to briefly describe the benefits of microservices architecture and disadvantages of the monolith architecture. We will talk on how to choose the best architecture for your system, for your case. Then we're going to discuss on how it is related to high loads and how to connect microservices and high loads and how to split a large system into separate smaller microservices. Then, when we know how it is related to high loads, and we're going to talk about design for failure, we're going to discuss what it is and how it's useful for our purpose. After that, we will go through main challenges, and we'll also talk about the solution for these challenges. We'll describe the problems that can occur during your transition and what are the main approaches for them to handle them. And in the end, we will take everything all together and see how we can apply our knowledge on real practical example. The first thing is, what is a software architecture? You can go through many books and websites and find many different definitions for software architecture. But the one that I like to share with others and stick with me is it is a method for documenting decisions made for the implementation of an information system. Decisions are presented as a connection between several components. And one of the most important thing is that architecture is always considered from different perspectives. You can come up with different frameworks, for example, YAML, when you can look or describe software architecture from different perspectives. For example, you can create sequence diagrams to describe the behavior of your system, or you can create use case diagrams to show in which way your system can be used, and etc. As a separate type of architecture, we can name monolithic architecture. And of course, there are many other types, but we're not going to look at them today because it's a very large topic and we're not going to cover in our talk. And okay, talking about monolithic architecture. As many of you already know, monolithic architecture is when you have a large piece of software. And of course, it's simpler for your development. It's very easy to deploy on service. And usually it has great performance and it's easy to manage from all perspectives. But when I was working at the world's largest social network, my main domain was the authentication and the authorization systems. And when we have more than 500 developers, then it was almost impossible to deploy some fixes, new code, and I had to wait for more than several days to have my code deployed. So of course, it presents different scalability issues. You cannot simply copy one large piece of software, because if one component fails, then the whole system fails. So it is tightly related to coupling between your components. And of course, deployment risks, as I've mentioned before, we had more than 500 developers, and when one of them had an error or some bug in his code, then we call them so-called trains with commits. The whole train was a total failure, so we had to roll back it. Okay, going to a much better approach, microservices architecture. It divides your large piece of software into smaller and loosely coupled microservices that are deployed independently. And of course, when you talk about its benefits, you don't have such problem as complex deployment or tightly coupled components. You have other problems that come up when you use microservice architecture. For example, the whole system costs more for you. It is more complex, so you have to find more SRE engineers for your company, for your team, to handle the infrastructure for your microservices. The software you use is more complex. For example, in almost every microservice architecture that I would work with, we had Kubernetes, and if team is not ready to work with such tools, it will be a bit painful for you to migrate. So we know the benefits and disadvantages of both types of architecture. So let's describe the use cases when microservices architecture might be a better choice. So when you have to scale your system, when your system is becoming more complex and always evolving, as an example, a social network, it always receives updates. And when you have to deploy and develop some applications independently, microservices is a great choice. Also, it is tightly connected with the team structure and ownership. In Monolith applications, it is usually hard to separate one component from another and to divide for different teams to use. The other use case is when you have technology diversity. For example, you have one microservice is written in Golang and the other in Java. So microservices architecture handles this case great. The other thing is the fault tolerance and isolation. When you want one part of the system to fail and not have other part of the system to fail. The other use case is when you have your application distributed across different countries or different parts of the world. The other use case is integration with third-party services, and when you have to speed up the development process. Or the simplest case, when you just want to modernize your legacy system. We also have to mention use cases when microservices will not suit well. For example, when your RPSs are not too big, for example, than 2 to 4 RPS, or when your application is very small, or expertise is limited, or maybe you have limited resources. This is a use case when you don't want to use microservices and better stick to your old technologies and architecture. As I've mentioned in the beginning, we'll briefly discuss on how microservices are related to high loads. I would say that high load is almost impossible when you are creating it using monolithic architecture, but I would not be 100% sincere with you, because the world's largest social networks, such as Facebook or VK.com, they historically were built using monolithic architecture, and developers had to invent different solutions to handle this. For example, to create transpilers to translate PHP code into C++ code, or developers had to create more perform the software like databases with much better performance, because high load is where the bottleneck is the CPU, and main challenges are the volume of data, the quality of data, the high rate of change, and high level of complexity. There is no clear definition of high load. We can only name some signs of it. For example, the system can no longer handle the current load, or common approaches are insufficient, or there's an urgent need to scale the infrastructure, or a single server is not enough to serve your customers. And also when hardware cannot cope with increased loads and existing tools cannot solve your problems. And when you are in such situation, when you have a very high RPSs, the main questions that you should consider are reliability, 2, scalability, and 3, ease of maintenance. I want you, from the all points that I'll mention today, these 3 are the key ones, so I want you to remember them. Design for failure. Some of you may know such person as Edward Murphy, and he said that anything that can go wrong will go wrong. And this is the principle that you should keep in mind when developing microservice architecture and high-load systems. Let's see a small example of it. For example, you have an order service which stores its orders in the database and sends an email when it receives a creation request. So everything is pretty simple, right? Then let's say that your email provider unexpectedly fails, but you still have to deliver your messages to the customers. So the great choice for you would be to add a fallback email service that you're going to use in case your main one fails. In the case of a service failure, external or internal to the system, it must be properly handled. And another good option for handling degradation is to use a cache service for your data storage. For example, your database cannot handle the load but you still have to serve your customers with many pages that they can watch their orders. And of course, they're going to face some problems when they want to create a new order. But for example, just to watch them or just to list them, the cache is enough. The other thing is that slightly touches microservices patterns is transactional outbox. When you have some messages in your system, when you have messages queue, you want to implement some guaranteed deliveries. And for that purpose, the transactional outbox pattern is the best. And if you're working with very important data, maybe with finances or personal data, this is the kind of pattern that must be used. Otherwise, you will face some unpleasant consequences. And we are moving to challenges that you're going to face when you are migrating your system from Monolith to microservices. And the first one is code complexity. As you see on the screenshot, this is a real screenshot that was taken when I was working on the code base of the social network, and I've just clicked the button to find the usages of ID function. And as you can see, We have more than 30,000 results, which is mind-blowing. And apart from it, the code is tightly coupled. It's usually hard to understand, and you spend days to understand how one component works. And of course, the development is slow, and you cannot deploy your code very fast when you have many developers working on the same parts. Of course, it's limited in its flexibility. It has high risk of bugs. It's almost impossible to cover with the tests, unit tests or integration tests, because you have the problem when you do not have interfaces, and basically your test environment use this production databases, so you cannot write your test code. In such cases, you have firstly you have to disconnect the data that is used in production from the code. The other thing that I think is the most important, it is a high entry. It is very hard to find new developers, especially if you use some old technologies like PHP and maybe Perl or other stuff like this. But what's more important is that even if you find one, it will take more than a year, 2 years for them to adapt to the code base, to understand processes and other stuff. And then developer works more than 3 years on such project. It is very hard to not lose him, because usually developer gets tired working on such bad quality code. So that introduces recruitment challenges. The second thing is data management and decoupling. We've mentioned this thing before, so we will go through solutions. First one is database per service. When you use exactly one database for your microservice, and you use event sourcing or change data capture to let the other microservices know that some data has changed. You may also use data replication and shared databases as temporary solutions. For example, you have module 1, module 2, and etc. that are working with the users table. And the first module is working with the username field. The second module is working with the password field. So how do we handle such situations? We can create, let's say, 2 microservices and divide our data into 2 separate tables. The first one is for users, and the second one is for addresses. And if our person data service needs some user info, any user info, then it can just make a GET request to the auth service. The next thing is the multi-layered caches. On the slide you can see a real example of how the caching could be implemented. I would not say that it is a great approach, but it's how it is in big systems that handle a lot of requests. You have your app, Monolithic app, and you have your local caches, maybe memory caches. And then you have a chain of caches, multi-layered caches. And one question could come to your mind. You can pause and try to answer it by yourself. But the answer is, when you want to simplify such systems, you have to go through all the complexity of the code that works with this chain. And usually it's mind-blowing. Microservices rely on communication between services, and it introduces latency, failure points, and complex dependencies. For such cases, you better use message queues, service discovery tools, and circuit breakers to not allow cascade failures. And usually for this, you have different libraries in your programming languages. We're going to talk about security, microservices. Of course, they increase the numbers of communication endpoints exposing the system to vulnerabilities. And to handle this, you can use API gateways to centralize authentication, authorization, and request validation. For example, you can use Istio gateway if you're using Kubernetes, or you can use many proxies like Nginx or Envoy or Hub Proxy. The other thing that you can use is Auth2 protocol and token-based authentication like JVTs for secure access control. And if you have a separate team or specialist, which responsibilities are connected with information security, you can implement penetration testing and audits. Of course, it is very hard to deploy distributed systems. So usually you want to have a separate team member, maybe DevOps engineer, that will handle all these tasks. And usually in his responsibilities, you can expect containerization and orchestration tools, CI/CD pipelines in GitLab or GitHub Actions, and of course, GitOps for infrastructure as a code, maybe such things as Argo CD and other stuff, maybe Ansible. To monitor a monolithic system, you can use maybe the things like Sentry or things like that, but to monitor many small applications, you'll have to use more complex approaches like logging, tools like Elk Stack, distributing tracing solutions. You can also implement distributing tracing by yourself, but if you are limited in your resources or don't want to, you can use ready solutions like Zipking. Also, it's a great choice to use service meshes like Istio. It's great for Kubernetes, and it also helps to increase the observability of your system. I've mentioned before that microservices introduced some HR problems, so teams and organizational resistance and skill gaps. Teams may resist change due to lack of familiarity with microservices or fear of increased workload, and you probably will have to organize training programs and workshops and maybe transition your responsibilities between team members and groups of developers. And to demonstrate that microservices approach can work with your system, you can create an MVP for your system, for your microservice, and then the team will understand the benefits and you'll more likely continue to migrate to microservices your other components of your system. Of course, working with legacy monoliths is hard, and the patterns that are going to help you are Strangler, its adapters, bridges, and different others. Also, you'll have to maintain some compatibility layers. The main concern that I have faced with when I was working with when I was migrating authentication part of the social network to microservices is that authentication is under a very high load, thousands of RPSs, and it was unacceptable to increase latency even by 1 or 2 microseconds. So I had to think about how to increase performance of my microservices or of my networking, of my infrastructure. For example, for interconnection, I've used gRPC protocol made by Google. We've also used Kubernetes to scale horizontally our system. And to measure the impact of the migration, we've used performance testing. It was very hard in the beginning to manage dependencies, but there are great solutions for such problems, such as event-driven architectures or API versioning with service contracts. A great tool, Swagger and OpenAI are the great choice for you to document your APIs and share it between teams. So we've covered almost every significant problem, and we've mentioned the solutions that can solve these problems. So let's go to the practical example, and we will try to create a token management service by moving code parts from one monolithic data code base. And the system itself just generates and checks APIX tokens. So we have our user, which provides session token like any string. And we have our legacy Monolith system. We have our web server, where our users send requests to. And our web service just sends users token to parse session function, which returns ID, IP, and expires date taken from database. How can I say? We want to migrate gradually. So the first thing we do is we create new microservices, let's call it token microservice, and we just copy our parse function. And we send two requests simultaneously, one to the Monolith version of this function and the other to microservice version of this function. Both of them are temporarily using sessions database, so they're sharing it. And if we compare our ID and IP and other data, and if it's equal, then we can gradually decrease the traffic from the monolithic function to microservice function. And we'll have something like this, where parse function is transferred to token microservice. But what if some other module uses sessions database? We have to migrate it as well. How do we do it? And the problem could be even worse if we have different caches between database and monolith. Here's a solution for this problem. We add a consumer to the monolith, and we add a producer to the microservice. And we use patterns that we have mentioned earlier, CDC pattern. So when our sessions database changes, then we capture changes and we're producing message into the message queue. The consumer will take the message from the message queue and update its local state in some other DB. And our other module will use data not from sessions database, but from other database. So we have decoupled two modules, one from another. And to make everything more concise, to keep it simpler, to make everything beautiful, we can transfer the logic from Monolith to the second microservice and left everything else untouched. That was it for today. In the end, I want to give you some recommendations on books that you can read and take useful information from. So the first one is Designing Data-Intensive Applications by Martin Klatman. And the second one is the website called Microservices.eu. This through will probably be enough to cover the main aspects of microservices. But if you want to go deeper, you can use distributed systems. It's free and to be find out the URL that I provided. And if you are familiar with Go, you can take a look at the book by Nick Jackson. So thank you for your attention, and I'm looking forward for your feedback. You can send me questions if you have in Telegram, or you can write me an email. So thank you once again, and have a nice day. Goodbye.